Type 0.1 plus 0.2 into any computer and it tells you 0.30000000000000004. And here's the part that breaks people's brains. That is not a bug. That's the computer working exactly as designed.
Wait, exactly as designed? You're telling me a billion-dollar machine that lands rockets can't add two numbers a third grader can?
That's exactly what I'm telling you. And the wild thing is, the reason isn't electrical or some rounding shortcut. It's mathematical. There are simple decimal numbers a computer is physically incapable of writing down.
Okay, but 0.1 isn't some crazy irrational number. It's a tenth. How can a computer not write a tenth?
Let me flip it back on you. Can you write 1/3 as a decimal? Perfectly. No rounding?
No. It's 0.3333 forever. It never ends.
Right. In base 10, 1/3 is impossible to write exactly. You need infinite digits. So you round it, and the moment you round, you've introduced a tiny error. That's not the computer's fault, that's just how our number system works.
So you're saying 0.1 is the computer's version of 1/3? It's a perfectly clean number to us, but a nightmare to the machine?
Exactly that. Here's the key, computers don't think in base 10. They think in base 2, binary. Everything is ones and zeros. And in binary, the only fractions you can write cleanly are halves, quarters, eighths, sixteenths, powers of 2.
Powers of 2. So 1/2 is fine, 1/4 is fine. But a tenth isn't a power of 2.
Bingo! To make 1/10 out of halves and quarters and eighths, you'd be adding pieces forever and never quite landing on it. In binary, 0.1 becomes a repeating pattern, 0.000110011, repeating to infinity.
So the computer does the same thing we do with 1/3. It throws up its hands and rounds.
It has to. A computer only has so many bits to store a number, usually 64. So it keeps the closest 64-bit approximation it can and chops off the rest. The stored value isn't quite 0.1. It's a hair too big.
And 0.2 has the same problem, I'm guessing.
Same problem, slightly too big as well. So when you add two numbers that are each a tiny bit off, the errors stack up. Add them and you get 0.30000000000000004. That little 4 at the end is the ghost of all that rounding.
This is the format they call floating point, right? The thing that shows up in every programming language?
Yeah, the official name is IEEE 754. It's a standard from the 1980s, and it's brilliant. It lets one chunk of memory represent everything from the size of an atom to the distance between galaxies. The trade-off is precision. It's approximate by nature.
Approximate is fine for galaxies. It is absolutely not fine for money. I feel like this is where the disasters start.
Oh, this is where it gets ugly. Imagine a bank doing millions of transactions a day, and every single one is off by a fraction of a penny because of floating point. Those fractions don't vanish, they accumulate.
There's that infamous story, the Vancouver Stock Exchange index in the 80s. They kept truncating instead of rounding on every recalculation.
That one's legendary. The index started at 1,000 points. Thanks to thousands of tiny truncation errors piling up every day, it slowly drifted down to around 520, when it should have been over 1,000. Half the value just evaporated into rounding noise.
Half. Because of decimals the computer couldn't store cleanly. So how do banks fix it? They can't just accept losing money to math.
2 big tricks. 1. They don't store dollars, they store cents as whole integers. No fractions, no floating point, no error. 2. They use special decimal types built to do base 10 math exactly, even though they're slower.
So the rule of thumb is basically, never, ever use floating point for money.
Burn it into your memory. And it's not just money. Games get wrecked by this too. In a lot of multiplayer games, both players' machines have to simulate the exact same physics to stay in sync.
And if floating point rounds differently on different hardware,
then the two simulations slowly drift apart. One player sees the rocket land here, the other sees it land over there, and suddenly the whole match desyncs. Developers have lost weeks hunting that bug, not realizing it was 0.1 plus 0.2 all along.
There's even a famous case where speedrunners exploit floating point. Tiny imprecisions in position let players clip through walls.
Right, the imprecision becomes a feature for them. But the deeper lesson is this: the computer isn't broken and it isn't dumb. It's doing flawless math in a number system where some of our everyday decimals simply don't exist.
It's almost humbling. We assume numbers are universal and exact, but exactness depends entirely on which base you're writing in. 1/3 breaks us. 1/10 breaks the machine.
So the next time someone shows you 0.3000000000000000004 and calls it a glitch, you'll know it's actually the most honest thing a computer can say. It's telling you the truth about the limits of representing reality with finite bits.
And honestly, once you understand it, you start seeing it everywhere, and you stop trusting that little equals sign quite so much.